Okay, welcome back. So we're going to continue talking about statistics, correlation, and regression. So problems 2 and 3, they're kind of nice problems in that we don't have to do any calculations. We just kind of have to engage the brain a little bit and then see what's going on. So I'll take this time to go over the problem, but at the same time I'll go over some other things that we could talk about. um, Remember that R is the symbol for correlation. Okay. I don't want you to have to memorize that formula. Calculator will produce this number for us, but do remember that it is going to be somewhere between -1 and +1. -1 just means there's a negative slope. +1 means there's a positive slope. A zero doesn't mean there's no relationship. It means there's no linear relationship, and that's always a tough part to remember. Okay, and this is for sample correlation. Your book doesn't really go into this. Okay, if you see this symbol here for correlation, okay, this is a Greek R. This is called rho. Okay, this is the Greek R. Okay, and it has the same kind of restrictions that it's going to be between -1 and +1. -1 means it's a negative slope. +1 means it's a positive slope. And again, a zero doesn't mean that there's no relationship. It just means there's no linear relationship. Okay, so a lot of people like to be fancy and they will use rho in terms of correlation, but in intro to stats classes, we try to make a big deal about, excuse me, having population versus sample. Okay, so you probably won't deal with that at all in this class. But if you ever see it outside of class, you'll know like it's not a P, it's a rho, and they're talking about correlation, and they're just trying to be fancy about this. So just to without putting any numbers in it, what they're looking at here is saying, well, is this? They're not, again, it's not an ink blot test. They're not trying to do a Rorschach test and like have you do this. So they're just saying the correlation coefficient. Say, well, it would be appropriate because that's kind of linear. Yeah, there's no turning points. That's really what I look for. Is there a big turning point in here? Because it looks like the variables have a linear relationship. Okay, it's nice that they include outliers, but we don't really have to worry about that just yet. We just want a linear relationship. Variables, I would say maybe a weak linear relationship. Okay, but I'll chance it and say a linear relationship and check. And I wonder how much they'll let us get away with. Okay, and they let us get away with that. Okay, so not too bad of a problem. All right, and then let's see, determine if the relationship between the two variables is positive or negative. Well, the number of hours a student spent studying in the last 24 hours and the number they spent sleeping in the past 24 hours. I'm going to make an assumption about when I was a student. Okay, so the choices were sleep or study. Okay, so if I was studying, right, how much time am I spending? If I'm going to have a lot of study time, right, how much free time do I have left? And it's going to go lower and lower and lower depending on how much time I'm studying. So my free time, my sleep time is going to go down. Okay, so if I'm going to go ahead and say study for a lot of hours, so hours spent studying, so we'll say hours studying and hours sleeping. Okay, so if I spend no hours studying or very few hours studying, then I probably spend a lot of hours sleeping because sleep is really important. And again, don't I'm generalizing, and it isn't really fair to a lot of students. I mean, I understand what it's like to be a student. I was one for too many years, but I don't mean to make that generalization. Okay, and it's not fair. I mean, a lot of people, especially you know millennials, Gen Z, you guys work a lot of hours. Okay, so don't let my gross generalization. I'm not trying to prejudice you. I'm not trying to make a big bad assumption on this. I'm just trying to play the game the way the book is trying to deal it to us. Okay, so we're going to say I would say that the less free time you have, the less amount of time you have sleeping. So that would say a negative slope here. Okay, and that's just what they're trying to trying to say is like, well, if just on a basic kind of an idea here, we could say that and say, look at that. Okay. And then we have some other spots. And what I'm going to do is I'm going to let this go for the next video because this will be a time. Okay. And we'll see what that's going to do for us. Okay. So again, the important thing to remember about correlation is correlation has to be between -1, +1. Just because if correlation happens to be 0, it just means there's no linear relationship. Okay. It doesn't mean there's no relationship. It's no linear relationship. And generally, you want to pick numbers that are going to go with that formula, right? We have r is equal to 1 over, don't memorize this. Okay, x minus x bar divided by a standard deviation of x's times y minus y bar divided by standard deviations of y's. Okay, we have to be able to calculate an average. We have to be able to calculate a standard deviation. I'm not asking you to do that. I'm just saying we have to be able to calculate it. So a lot of things that you might think are correlated, blonde hair and blue eyes, we don't have numbers to put in here. So just be real careful what you say is correlated, especially when you're taking a stats class. Okay. A lot of people use the word as a layperson. I get what they're trying to say, but in a statistics class, it's not really the way we want to use it. We want to have measurements, we want to have X's and averages and standard deviations to be able to calculate this value. Okay, so just want to remind us of that. And we'll get started with one of these in the next video. Okay, so thank you for tuning in, and I will see you in the next video.